Hello everybody and welcome to your next AllegroHD tutorial. It is now 6:06 a.m. in the morning. I haven't really slept yet, so sorry if I might seem a little slow in this tutorial, but I'm going to teach it to the best of my ability right now. Okay, so let us get started. So some notable changes in our program is that instead of having one block size, I've changed it to having block size X and block size Y. The reason being is that the textures that we're going to be loading in, or the sprites we're going to be loading in, that I'm going to be loading in, is of 40 by 32. So I decided to store them right here. So what are we going to be learning in this tutorial? Well, essentially we're going to be learning how to load textures, different textures for different maps, and how to incorporate them within our program. So there is still a lot after this tutorial. There's two more things that I want to teach you about in the tutorial series. I want to teach you how to load with IDs and loading on the fly, and you guys will learn about that in the next two tutorials. So what is gonna go on here? Basically each map has its own custom tile set. If you've used say RPG Maker like XP, or you've used different engines, they all have their own tile set. And once you play a game, sometimes some tiles will be repeated, but sometimes they all have their own distinct own tiles. So say you're playing an RPG and one map you're in a wasteland. Okay, so sometimes some textures in that wasteland might include of sand, barren trees, some leaves, etc., etc. Whereas if you're in a town, you might need some house tiles, some window tiles, grass tiles, etc., etc. So what we want to do is that we want to load the required textures that we need in our program. We can always say that we could always load all the textures all in once and then just ID them and then display them here, which I'm going to be showing you how to do. But if you want to just load the certain textures that you need for that certain map, then this is the way to go about it. This way is really effective because you only load what you actually need. Now if you need, like if a next map is using a ground tile, ground.bmp, then you might want to have a loading algorithm which says that if it's already loaded, then you don't load it again. But this way, if you say you have 20 maps and the person only, if you want to load dynamically, and say the person only plays 3 levels, then you've only loaded the amount of textures you need for 3 levels, and you haven't loaded the amount of textures you need for 20 levels. If you want, you could load all the levels all at once, which is highly recommended in most cases. But if you really didn't want to, and you want to load it dynamically, or load it by level to level basis, or if you want to load it like load the first 3 levels and then load the next 3, etc., etc., then you could also do that as well. When it comes to making games, it's basically about improvising and going with the flow and going what your instincts tell you what to do. Sometimes there is a set way to do it, but sometimes you can modify it to suit your needs or suit the game's needs. So like if it needs optimization, you might need to tweak it a bit. Anyways, I've talked too much, so let us get into it. So basically, if you notice the map right here, I've replaced the zeros with -1s, and the -1s are going to represent the sky, or represent that there's no texture there. Okay, and everything that's greater than -1 is going to represent a 0. So let us look at this texture as an array. So if I store these two values in an array, the array at index 0 will be ground.bmp, and the array at index 1 will be platform.bmp. So basically, I'm saying that all the zeros are going to represent ground, are going to represent, sorry, I flipped that around to test something. So all the zeros are going to be the platform, and all the ones are going to be the ground. Okay, that's simple enough. So when we store that in an array, basically we're going to say that when we detect when it says to draw the map 1, we want to look for the texture in the index 1, and then we want to draw that onto the screen. So simple enough. So let's get into our program. So right now we have an enum called load state, and that is going to it's going to incorporate texture and map. So it's going to let us know what are we loading. Are we loading in a texture or are we loading in a map? Because it won't know by itself. So right now, if you notice here, I have a square bracket that says texture followed by a closing square bracket, and I have map followed by a closing square bracket. So basically this is going to indicate to us or to our program whether we are loading in textures or whether we're loading in the map. So our enum is essentially going to let us know, or it's going to let us know what we're going to load in, and our integer state right here is actually going to tell us what state we're actually in. So when you're actually giving a value to state, you could say that state is equal to load state, and then you would put ::, and you could put whatever you want to identify it as load state, as well as you could easily just put the name right there, because since the two different enums cannot be given the same value within its vicinity or whatever, it's much like a variable. Each thing in here is treated much like a variable. You can't have it repeated, so it's much like a define or a variable or whatever. So you can just simply put that state is equal to texture. Doesn't matter, it's not wrong coding, you could do that, and that's what my comment is basically saying down there. But for right now, we don't want to establish it as anything. So we're gonna say what we're gonna do. We're gonna go to our load map function right now, and we've added one thing to the parameters after our map. And one thing I forgot to show you guys last tutorial was that you have to put the ampersand there for map as a reference to it. Since we're changing the values we're adding to map, we need to put the ampersand there. Otherwise, the map variable actually won't indeed get changed. So we say we're making another vector called texture, and it's going to store bitmaps. And remember to put the ampersand there. So the load map function starts off the same as before, and I've got rid of load counter x and load counter y because we did not really need those. So we open the file, and we have a temporary string, and we have our temporary vector. So we say if the file is open, then we want to actually scroll till the end of the file. So we clear the vector like we did before, and we want to get the a line within our text file like we did before and store it in temp line. So we're gonna check to see that if the line contains the word texture. This is basically what it's saying. So if the temp line can find the word texture, then we say that state is equal to load state : texture, or if you wanted, you could just put state is equal to texture. Either one is fine. And then we say else if you can find map, if the word map within the text file, then we set the state to load state. And if you want to be more specific, you could put the actual thing, like the actual square brackets in there if you want to get technical and stuff. You wouldn't want to say that if temp line is equal to the square brackets texture, etc., because if you accidentally leave some trailing spaces within your text file, then that could be detrimental to your program. I am going to be teaching you how to remove the trailing white spaces, so that might not be an issue to you, but it's up to you. I just rather use the find function just to make it a bit easier and less error prone. So if we find the word texture, we're gonna set our state to texture, and if we find the word map, then we're gonna set our state to map. and then we put the continue keyword, because after we set our state, we don't want to do anything within our program. So what continue is basically going to do is it reset it back to the top of the while loop again. Okay, and if it was a for loop, it would put it back to the top of the for loop and execute whichever statement is in the last statement block. Anyways, so we use the switch statement right here, much like an if statement. If you don't know switch statements, I suggest you look at that. But we use this switch statement, and we say that if state is equal to load state texture. So if we're going to be loading in a texture, then we say that if temp line, the length of the temp line is greater than 0, then we're going to add to our texture vector. So we say texture.pushback, and we load the bitmap the same way, and we say templine.c_string to change it to a constant char, and then we put null in here like we normally do. So this is basically loading in our textures, and we use break because we don't need to execute anything else within the switch statement. So that is simply adding to our textures. And the reason why we use a vector, once again, is that we might not know how many textures that we're going to be loading into each map. Each map could have a different amount of textures. So to make it more flexible, we use vectors so it can accommodate for how many type of textures we actually need within that map. So now that we got that set, we are going to look at how we actually load the map. So we say that if the state is equal to map, then we want to erase the trailing spaces, because that can actually cause errors in our program. So right now, there is, as you can see, there is no trailing spaces. But say I went like this and I saved it. Now when it comes to drawing our map, they can replace those spaces as a different value. It can replace it as 0. I tried to test it without removing the trailing spaces, and it replaced the spaces with a value of 0. And therefore it still drew the map. I got no error codes, but it ended up drawing zeros where I didn't want them to draw it, and then it ended up drawing random platforms where I didn't want them. So make sure you remove the trailing spaces, and you can easily do that by using templine.erase, templine.find_last_not_of, and then you execute this statement right here, and it will erase all the trailing spaces. And if you go to C++.com or I think or whatever, it will give you a reference to it and explain it more in depth. I don't really want to get too in depth into that. So before I just said while str. What you want to do is, if we say, just like when we're loading in maps, you want to say while not str.eof. So just cycling to the end of our string or our string stream. And so everything else here is exactly the same as last tutorial. And after we put map.pushback, we just want to put break there, letting us know that that's the end of our case within our switch statement. So loading maps is essentially, right now it got a little bit harder, a little bit more code, but should be fairly straightforward. So if you go to our draw map function, and I hope I haven't lost you guys from now, but our draw map function, if you notice that we don't need the ampersand because we don't change the map's value, and we've added a new parameter with the texture as well. We don't need the ampersand because we don't change the texture's value. So pay attention right here. So we say that if map ij is greater than -1, then we actually want to draw the corresponding texture to the position that we want to draw on the screen. So how do we do this? So we're going to put draw_sprite. We're drawing our sprite to the buffer, and we need to know which sprite we should draw. That's where our map comes in. So if the value of map ij is equal to 0, then it lets us know that we should draw the texture in the index 0, which in turn is going to be the platform. So once we get to this section of the code, it's going to say map ij is equal to 0, and so it's going to say basically draw texture 0, and then it's going to draw our platform image. So yeah, that's what it basically does. And then we say, when we draw, we say j times block size x, and then I times block size y for our position to where to draw it. And we say that if it is less than or equal to -1, then we want to draw a light blue rectangle to represent the sky, or a null image or whatever. And we do the exact same thing, but remember to add block size x and block size y, etc., etc. And then that's basically it for our program. All we need to do is that we just need to put std vector, and we need to make the vector of type bitmap. Don't forget the asterisk there. Sorry, I can't really say that word properly. And we need to name it texture, and we added a new parameter there, so we just need to put texture there and put the word texture there, and our program should run effectively and efficiently. So if we press F5 to run our program, so if you run in your program, you should get something like this, or a result. Your map should be drawn the way you want to be drawn with the textures you have. So that is it for this tutorial. Hope you enjoyed this. Thanks for watching, and bye.